Hello everyone and welcome back. My name is Mr. Kowalt, and in this video again I'm going to be going over a second example of how to use the method of successive approximations to solve an equilibrium problem. So let's get into this. Alright, so last time I did an acid dissociation problem where you had a weak acid and it was dissociating, and you had to figure out what the end or equilibrium concentrations are. And of course, the reason for that is so you can find the pH value. Now, in my last video, I didn't calculate or show you how to calculate the pH value, since that really wasn't the point of the video. The point was to show you how to use the method of successive approximations. In this video, again, I'm going to show you how to use the method again to avoid using the quadratic formula or some higher order polynomials. And this is again used in cases where the x is negligible assumption doesn't work. It doesn't pass the 5% rule. And so if it doesn't pass the 5% rule, you could either use the quadratic formula or solve some higher order polynomial, or you could use the method of successive approximations. So let's get into this. Okay, so here's my example. I have HNO2. That's a weak acid. It's going to be reacting with water. And I have 0 H3O plus, and I have this. Now, this is a buffer situation where I have the acid and the conjugate base in solution. So we're going to find the pH of this buffer. So what we need to do is find the amount of H plus concentration, or the hydronium concentration at equilibrium for this buffer. So let's get started. So here I have 0 hydronium. So because it's 0, it's got to shift in this direction to create more hydronium, because we can't have 0 of any species at equilibrium. So we know it's going to shift this way. So that means I'm going to lose an X amount here, because notice it's a 1:1:1 concentration. It's a 1:1 ratio for the stoichiometric amounts. So for every X amount I lose here, I'm going to gain an X amount here, and I'm going to gain an X amount there. Now, notice I have water here. I'm ignoring water because in all equilibrium expressions, we ignore liquids and solids. Water is a liquid, so we're going to ignore that. Okay, so here, add these together, I get 0.10 minus X, and this is just going to be 0 plus X is just X, and then this plus this gives me 0.030 plus X. And so now I have the equilibrium concentrations in terms of X. Now I can plug that into my K expression, my equilibrium constant expression. They gave us the Ka value. This is the equilibrium dissociation or acid dissociation constant. It's basically an equilibrium constant for acids. So here, this is our Ka value. That's going to be equal to, and the expression is going to be products over reactants. So here I have hydronium ion, so it's H3O plus raised to the 1 power, because the coefficient is a 1. And we're going to multiply that by the concentration of NO2 minus, and that's over the concentration of HNO2, the acid. And so now we have the expression. We can now plug in the equilibrium concentrations in terms of X. So this is going to be the hydronium ion, that's going to be X. So that's going to be X times, and then the concentration of NO2 minus, which is this here. So that's going to be 0.030 plus X divided by the concentration of HNO2, which is this expression right there. That's the equilibrium expression. And so that's going to be 0.10 minus x. And so now we have our equilibrium expression in terms of x. So now we can go ahead and try the x is negligible assumption, and we'll find that it won't work. You can usually tell it won't work if you look at the Ka value and compare it to your concentrations. Here we have 1 times 10 to the negative 1. Here we have 3 times 10 to the negative 2. That's really close to the Ka value, so probably not going to work. But again, as I said in my last video, you always want to do the x is negligible approximation anyway, because if it doesn't pass, then you can do the method of successive approximations, and which is the first part of which is to do this. So we're already doing the first part of that. So we'll go ahead and do the negligible part. So we'll assume that this is so small that it's negligible. So we'll get rid of the x there. So subtracting x from this is not going to change anything. And then adding x to this is not going to change anything. So it's so small it doesn't really change anything. It's essentially like saying x is 0, but we'll find out what x is and we'll have a better approximation than just 0. Okay, so now I have this. So then it's this divided by this, so I get, let me rewrite it over here. So 7.2 times 10 to the negative 4 is now equal to x times 0.030 divided by 0.10. Okay, so now we just have to divide those two. And when I divide those two, I should be able to do it in my head, but let's just use the calculator. 0.03 divided by 0.1, probably equal, so 0.3, that's what I thought. So 0.3, so this is now going to be equal to, so 7.2 times 10 to the negative 4 is equal to x times 0.3. Make sure I got that right. Yeah, 0.3. Okay, and we should put a 0 in there because this has 2 sig figs, that has 2 sig figs, so we should have 2 sig figs there. And now all I have to do is just divide by 0.3. 0, so 0.30, divide this by 0.30. That cancels out, and I get x. When you divide that, you get x is equal to 0.0216. So 0.0216, and we'll call that x1. And so I have a third digit there. I'm keeping an extra digit to avoid rounding errors. So now I can use this to calculate what the 5%, what the error is, and see if it's less than 5%. Okay, so I'm going to take this and I'm going to relate it to the original concentration. Okay, and so when I do this, let's see. Let's see here. So I'm going to go ahead and calculate that. But first, I just realized I made a mistake. So that's not 0.016. That should be 0.0. What did I calculate? Sorry about that. 00240. 00240. Okay, so that's the correct value. So again, that's my first x. Now what I'm going to do is calculate the value, and I want to use, again, look, I have two concentrations here. I want to use the concentration that's going to give me the biggest error, right? So so here I have a smaller concentration, and here I have a larger concentration. So the larger concentration is actually going to be give me a smaller error. So if I'm going to use this, this is closer to my x value, so that's going to give me a larger percentage since this is smaller. I'm going to divide by this. So the smaller number I divide by, the closer it is to this, then that's the larger percentage. So I'm going to go ahead and do that. And so I'm going to take my 0.0024, divide that by 0.030, multiply by 100, and you'll get about 8%. So 8% error, that's definitely larger than 5% that's our threshold for accepting your x value as negligible. So this is not, so the x is negligible wasn't legitimate, wasn't valid. So what do we do now? Well, since we have our first x value, the process or the method of successive approximations tells us that we just plug this back into our original expression here we plug it in for x. So all we have to do is plug it in for x, do the calculation, and solve for x again and see what we get. And again, we keep doing that. It's an iterative process, meaning we keep doing the same thing over and over again until we get the same answer twice in a row. So let's do it again and see what happens. So I'll erase this. Okay, so then I have, of course, this will be 7.2 times 10 to the negative 4, and that's going to be equal to x times, and that's going to be 0.030 minus this x here that we just discovered, and that's going to be 0.00240. And that's going to be divided by what's on the bottom here. That's going to be 0.10, again, minus x that we just found. So that's going to be 0.0240. Okay, so we're going to put that in 0.00240. All right, so now we have to just do the math here. So we'll subtract this. So let's go ahead and do that. So we have 0.030 minus 0.00240 equals, and that's going to give us 0.0276. So then this 7.2 times 10 to the negative 4 is going to be equal to x times 0.0276 divided by, and then we're going to subtract these two. So we have 0.10 minus 0.0, oops, I forgot oh no, I got it. So we're going to subtract this minus 0.00240 equals, and there we get 0.0976. So now all we have to do is divide those two. So let's go ahead and divide those. So 0.0276 divided by 0.0976 equals, and that's going to give us 7.2 times 10 to the negative 4 is equal to x times 2, oops, that should be 0.2. Oops. Dropped my calculator. So that's going to be 0.2827. Okay, so I got more digits than I need. And so now all I need to do at this point is divide both sides by 0.2827. So let's go ahead and do that. So I'm going to divide this by 0.2827. Divide this side by 0.2827. And when I do that, I get x2, my second x value. Let's go ahead and figure this out. So I got 7.2 times 10 to the negative 4 divided by 0.2827 equals, and this time I get 0.00254. Okay, so notice I have a difference here now. So my second x value is different from the first, so that means I got to do it again. So remember, I'm going to do this until I get a second, two of the same values again in a row. And notice I'm keeping an extra digit here in order to avoid any rounding errors or anything like that. So here, if I'm going to do it again, I'm looking to get that number again. So let's go ahead and do the third iteration. So again, I'm going to take this and I'm going to add my second x value in and do the same calculation again. Okay, so here again I have 7.2 times 10 to the negative 4. That's going to be equal to x times 0.030 minus, and then my second x value, that's going to be 0.00254, and then divide that by 0.10 minus, oops, that should be a plus x, sorry. That should be a plus x. Hold on a second. Oops, did I do plus before? Oops, I think I made a mistake here. So this was x1 is equal to 0.00240. I think I subtracted last time, so let's go ahead and do that again really quickly. Sorry about that. All right, let me bring this lower. So 7.2 times 10 to the negative 4 is equal to, and that's going to be x times 0.030 plus, sorry, it's plus 0.00240, and then this is going to be 0.10 minus 0.00240, and then when I do that, right, I get 7.2 times 10 to the negative 4 times x, and then I'm going to subtract, or I'm going to add, right, so this time I'm going to add 0.03 plus 0.0024 equals, yeah, that's much better. So that's going to be 0.0324. And then I'm going to subtract that. That I did correct. 0.1 minus 0.0024 equals, hold on a second, 0.1 minus 0.0024 equals, that's going to be 0.0976, and then when I divide those two, I get 0.03 0.24 divided by 0.0976 equals, and so now I get here 7.2 times 10 to the negative 4 is equal to x times 0.3319. And so now this time I just divide both sides by this, and then when I do that I get x2 equals 0.0216, I believe. 0.00216. Yeah, so I get 0.00216. So now, that was the second time. So the first, I made a mistake there, so this should be the correct answer. So now I'm going to take that and I'm going to do it a third time and see if I get that same answer. So I take 7.2 times 10 to the negative 4. That's going to be equal to x times 0.030 plus, not minus, plus this. So it's going to be 0.0016, or 216, sorry. 216 over x minus 0.00216. So then, finally, I'm going to take 0.030 plus 0.00216 equals, that's going to give me, so 7.2 times 10 to the negative 4 is going to be equal to x times 0.03216 divided by, and then I'm going to take, oh, this should be the, not x, but 0.10. So I'm going to take 0.10 minus 0.00216 equals, and that's going to be 0.09784. And so now I'm going to take these numbers and divide them. So I get 0.03216 divided by 0.09784 equals, and I get 7.2 times 10 to the negative 4 is equal to x times 0.3286. And so now all I have to do is divide both sides by this. So when I divide, I get, what do I get? So I get 7.2 times 10 to the negative 4 divided by 0.3286 equals, and I get 2.1, yeah, 2.18, so 0.0021, actually I get a 9. Okay, so notice that they're not the same yet, so I got to do it again. So for a fourth time, so you'll notice that the difference is the change between them is getting smaller and smaller, right? So we're getting close. The fourth one might do it. So let's go ahead and do a fourth one. So I'm going to take 7.2 times 10 to the negative 4 equals, and it's going to be x times, here, let me bring this lower. Times 10 to the negative 4 is equal to x times, and then I'm at 0.030 minus, or plus x, but this time the x is 0.00219, and then I'm going to divide that by 0.10 minus 0.00219. And so let's go ahead and do that calculation. So in this case, again, we have 0.03 plus 0.00219 equals, and here we're going to get 7.2 times 10 to the negative 4 is equal to x times 0.03219. And we're going to divide that by, and we're going to subtract these two, so 0.10 minus, oops, okay, we're subtracting these two, 0.10 minus 0.00219, oops, equals, and we get 0.09781, and now we divide those two, and so we're going to take 0.03219 divided by 0.09781 equals, and now we have 7.2 times 10 to the negative 4 is equal to x times 0.3291. And now we're going to divide by both sides. So we divide by 0.3291. Divide this side by 0.3291. And so when we do that calculation, 7.2 times 10 to the negative 4 divided by 0.3291 equals, and we get x to the 4th equals 0.00218. So we're getting really close, right? But where it's not the exact same number, right? So you would do it again one last time. This time I'm going to skip the calculation since we've done it enough. You guys should know what the calculation is now. So we're going to go ahead and set it up. So I have 7.2 times 10 to the negative 4 is equal to x times 0.030 plus x over, and that x this time is going to be 0.00219. 218. And then on the bottom, it's going to be 0.10 minus 0.00218. And so let me do the calculations. I said I would skip it, but I'm going to do it anyway. So 0.03 minus 0.00218 equals, so it's going to be 7.2 times 10 to the negative 4 equals x times 0.02782. Wait, let me double check it. Oh, no, hold on, sorry. I think I subtracted again. That doesn't make sense. So 0.03 plus 0.00218 equals, oh, that's so much better. 0.03218. And so now I'm going to take this one, 0.10 minus 0.00218 equals, and then I'm going to get 0.09782. Okay, so now I'm going to divide that. So 0.03218 divided by 0.09782 equals, and so now I get 7.2 times 10 to the negative 4 equal to x times 0.3289. And so now I'm going to divide both sides by divide this by 0.3289. Divide this side by 0.3289. And when I do that, let's see what I get. Oops, I'm cutting this off. Here we go. Okay, so 7.2 times 10 to the negative 4 divided by 0.3289 equals, and I get 0.0, so for x5, I get 0.00218. So in this case, it took me 5 tries, but notice that I now have the same number twice in a row, so my x value is 0.00218. So that is going to be the actual value of the x, or the change in my concentration, and in this case it'll be the hydronium ion concentration. So this is what the hydronium ion concentration is going to be, because that's, oops, this one here is going to be, so this is going to be x. The pH is dependent on x, so to find the pH, right, that's going to be equal to the negative log of the x value of the H plus concentration, or hydronium concentration. So when you figure that out, pH is going to be equal to negative log of 0.00218. And so when you calculate that, you get, excuse me, 2.66. So the pH is equal to 2.66 with 2 sig figs, right? So remember, we kept an extra sig fig. This is actually 2 sig figs in here, and and that leads us to a pH that has 2 decimal points. So remember, whenever you're taking the log of a measurement, the number of decimal places in the log is going to be equal to the number of significant figures in the measurement that you took the log of, right? So since we have two sig figs here, the 8 doesn't count, right? Just the first two. So this has 2 sig figs, so therefore we end up with 2 decimal places in our pH. So we have 3 digits here instead of just 2, right? So sig figs here in your measurement translates into decimal places here. So 2 sig figs here, 2 decimal places there. I hope this was helpful. It took longer than expected, so right, we had to do it 5 times. But again, if you do this enough and you know how to do it on your calculator really well, you'll be able to do this a lot more quickly than if you were to use the the quadratic formula or try to solve a higher order polynomial. So I hope that's helpful. If it was helpful, if you learned a lot from this video, then please by all means like the video, share the video, hit that like button somewhere over there. Also hit the notification bell, subscribe to my channel, by the way, help me out, man. Hit that notification bell. When you do that, click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.